Welcome to the lecture series on object oriented analysis and design. So, without going through the earlier slides, it is here from 2002. Most certainly object oriented became synonymous with UML, and by saying so, it is not an indicator that this is the ultimate. U is only unified. We found a method of unification, we found a method of modeling, well supported, well structured, giving us that quick assurance that in a field called software engineering, where we do not see anything happening on ground until the fag end, and we keep hoping that at the time when it happens correctly, we found a method, we found a way of cross checking, we found a way of bringing multiple contexts, multiple stakeholders, multiple domains, multiple ways of life cycling, multiple ways of practicing, management techniques, systems, everything together. We are quite happy that this particular unified modeling language, not an ultimate language, but is a very generic, very good and a simple way of just using 9 diagrams to express a very complex exercise of software engineering. And please note that it is something which I have adapted from an old book, 2001 book, and it is just redrawn for the purpose to make it simpler. In a way it is oversimplification. It is not so easy to see this 1.1, 1.2, 1.3, but this book has been very nicely written, and it's nice to understand that it happens like this. UML 2.0 is what we thought, and ever since, not only UML, this tag 2.0 started appearing everywhere. It was a runaway success, and it had great pioneers behind it. So, this tag called 2.0 began to appear everywhere. UML was becoming synonymous with object oriented to a point where even a tool in object oriented was called UML. Whatever it is, everything is UML, nothing else beyond UML, and it served the purpose. It served the purpose well. We learnt a new way of thinking without too many tears, and then we said that yes, it is easy, it is seamless, it is easily understandable. Who are the partners? Hewlett Packard, IBM, Microsoft, Oracle, Illogics, IntelliCorp, System House, ObjectTime, Unisys, Sterling Software, Rational Software, Icon Computing, Platinum Technology, and others. They were good leaders in field of technology, not only market leaders, but good technical hands were there in all these organizations. Very impressive partnership that UML got, and once it was such a strong partnership, we can readily understand that it is not the case of academic research industry anymore. It is a practical way of addressing complexity with which we have progressed in software engineering, without which what is the problem? It is only a puzzle, it is only a program. Unless we celebrate complexity, we cannot breathe meaning into what is called software engineering. A language for capturing and expressing knowledge, a tool for system discovery and development, a tool for visual development modeling, a set of well founded guidelines, a milestone generator, a popular therefore supported tool, a visual programming language, a database specification tool, a development process, a panacea, a quality guarantee. These were always spoken of. What was achieved? It was this that was achieved. Popular, milestone generator, set of well founded guidelines, all these ideas were there, sweeping across 6 decades of software engineering and the way we have been working. Please note that this field has attracted some of the best minds. There is no second opinion about it. It was a sheer challenge to get on to this field. So, we did only this much, but the quest for having a visual programming language, that became a separate paradigm called visual paradigm. Database specification tool, that became a separate paradigm, database paradigm. A panacea, till today we do not know what it is, we do not even have a silver bullet. A quality guarantee, never. It does not guarantee anything. The technology does not guarantee anything, the language does not guarantee anything. It is the ingenuity of the people who are using these tools that have to make it happen. So, we have been thus saying that a development process, software development life cycle is not talking about any development process, no process definition, it is there, build everything in your software engineering around this, and we started calling it object oriented software engineering, not to conflict with Ivar Jacobson's method, but it is a field called object oriented software engineering. What can it do for you? Better think out and document your system before implementing it. It remains a discipline in the way we have been doing computing, that we should not rush to the machine. Like Lincoln was telling that if you have to cut out a tree with an axe, what would you do? Let us say the time bound is 3 hours. Lincoln seemed to have remarked that something like 2.5 hours he will spend sharpening the axe, and once he begins cutting it, the tree will automatically be easy to cut. So, we have been trying to do that. Computing is not rushing to the keyboard and the machine at all. Early days of computing was like that. It is more like pen and paper work. You need to redraft, rewrite, do the exercise, but then it is what UML is helping us do, and it is good. It is an automated tool, and we talk about more complexity that is more important for us. Forecast your system, determine islands of reusability, lower development costs, plan and analyze your logic, make the right decisions at an early stage, better deploy the system for efficient memory, processor usage, easier maintenance on well documented systems, lower maintenance cost, establish a communication standard, minimize lead in costs. All these are good. We keep saying the same old story about many things listed here, that yes, this is what we were trying to do, but in understanding why we could not complete that, we learn more about what exactly is happening on ground. So, that is where the handles come. If you tell this and if you do, well, yes, you have done it. You have done it, you can score, but then if you do not, then we know more about what exactly is happening on ground. There is not a license not to do more, but then you will have to make business constraint as the lead because of that reason. You have invested, you have to get a return on investment. Therefore, the impetus is to do what you thought you will do in all these points. Every point you want to do what you have thought you should do. That is when business thrives. That is where we draw a distinction. UML components, views, functional, non-functional, organizational, diagrams, model elements, symbology, general mechanisms, adornments, notes, specifications. So, UML has brought in a simple way of talking about multiple views. Everyone will have a view of his or her own, which is the best part of architecting. The architect always listens to all possible views, and they may debunk every view and come up with something else, that's secondary, but that's the way we want to build that. Multiple views will be there. What is the best part of UML is it clearly tells out of these views which can become functional, which can become non-functional, which can become organizational. For quite some time, once again in this method we raced towards functional. Get the functional first. Out of all the views, it's a good idea. So far, we did not have a way which is acceptable everywhere, that out of all the views that were collected, we assimilated them like this, and people will say, yes, you have assimilated different views. Otherwise, that comment will keep on happening, that none of the views have been taken into account, something else happened. All of us expressed our views, but something which is completely not there in the view happened. So, we found a way of unified modeling language at that complexity to race towards functional. Then we started understanding that non-functional is equally important as functional. That is when people are valued for the views. Most of the times views are necessary when we are focusing on non-functional and organizational. That is exactly what is making your way, your context different from others. If everything is distillable as functional, then we think that can happen anywhere. The non-functional organizational along with the functional will give you that distinguishing aspect of what is it on your hand, your desk, what is it that you want to do. Then came the diagrams, not 1 or 2, 9 diagrams to tell that this is how we will cross check functional, non-functional, organizational. We will turn it around, do it in all these cases, and then say that yes, it is factoring all these model elements, symbology, notation, general mechanisms like notes, specifications. On top of it, UML got in what is called an object constraint language. The more you look at non-functional requirements, the more you look at organizational, the idea of constraints begin to become very conspicuous. It becomes very apparent. Constraints are very necessary. We have again said, everything that we told is a good problem, we have branched off also. Constraint programming, constraint based development, everything was happening. There are so many things that will keep happening. It is something which is so intellectually stimulating and very creative that tomorrow we will create totally different method, and for our purpose it may be all right. Aesthetic, and why should I interoperate with others? Unless you understand that all this will have to eventually thrive in a networked context. And why networked context? These are all different questions, seriously challenging questions. As we progress, we will understand the case for diagrams: aesthetic, descriptive, compressive, simple, understandable, universal, formalizable, standardizable. So, these diagrams will satisfy all these requirements without saying much. So, it is not an accident that after 2002 object oriented became completely synonymous with UML and vice versa. Whatever we were talking about object oriented was only unified modeling language, and the 2.0 tag started appearing everywhere. And this is not entirely new to us in software. When we were developing, we were always quipping, saying that until version 2 happens, don't believe anything is happening at all. We are building software, only version 2 of that software is likely to be taken a bit seriously. Version 3 will stabilize. Those were the days of versioning, version control. And what has taken away the charm of waiting for the next version? The open source. Early releases, many versions, tracking, source code control system, and the charm in that versioning was virtually wiped out. We are no more talking about versioning, version control, which was the essence of software development. Instead, we were talking like this: 2.0 and so on and so forth. Aesthetic, descriptive, compressive, simple, understandable, universal, formalizable, standardizable. That is the case for diagrams. Again, all diagrams do not necessarily mean they are better than 1000 words. Diagrams that befit such descriptions usually are much better than 1000 words, usually that befit this description. If you can arrive at those diagrams, then yes, you are telling exactly what is on the mind without becoming verbose. The case against diagrams, it is not inherent knowledge. We do not think in these diagrams at all. The quest for what we called what you think you should be able to say, what you say you should be able to do seamlessly, that is the best for the human. It takes care of everything. What you think you say, what you say you do, that is it, nothing more. There is no further description necessary, everything is spoken of, everything is seen, everything is visible, or transparency at its best. We do not think in diagrams at all, it is not our inherent knowledge. Easily cluttered, 9 diagrams is too much, takes time, we get completely immersed in all these diagrams. Common comments, these are all very common comments. It requires some training, lot of training, not necessarily revealing, they do not tell much, must be liked to be accepted and used, effort to draw. So, it was a serious training that was required. It is not that we were simply called for training. We were there, few of our colleagues were called in, and eventually to go through the full battery of all the lectures, examinations, and I got my certification on UML. Rational Rose has conducted. That's how the first set of training programs were there. It became a very good tool. Rational Rose again became synonymous with UML, object oriented tool. There were other tools. Luck was mine that I was also associated with some other tool development, and it was not so easy for us to build these two as what to say completely different commercial exercises also in some sense. So, limited scoping, limited role playing. So, Rational Rose happened. We had 5 days of contact, and then we had to go through the battery of examinations and then get certified. It happens like that, not necessarily revealing, must be liked to be accepted and used, effort to draw. So, what are the UML diagrams? Use case, static structure, object, class, interaction, sequence, collaboration, state, activity, implementation, component, and deployment. Too many diagrams? So, what do we do now? We strongly think that the idea of class, sequence, state, and use case are easy, because we learnt through that simple example of a vending machine what is the use case, what is the user concentrating on. Please recall the very first example of a vending machine. They want to buy a snack, a limit on the calorie value, a limit on the amount. They can combine many snacks, but the calorie value cannot shoot up, the money value cannot shoot up. Money is put in, change is got, the snack is got, the tray is got. Same simple ideas, use case. We will expand on it later. Use case is something which we will do it as a separate lecture later. Class, sequence, state. State, the sequential way in which we write the methods, more or less familiar, but then clubbing them together as static structure, interaction, activity, implementation is a nice way of building the software which we are aiming at. Built on those 4 simple cornerstones which are in pink, classifying what we want to do using these UML diagrams has been very helpful to us. Relation of actors to system functions, static class structure, object, state, sequence, collaboration, activity, component, deployment. So, sequence is a sequence of messages which will automatically indicate what is happening, the send, receive, what is sent, what is received. Introduction to UML, what constitutes the UML? Just to quickly recap, these are the things that we were talking about. It is a language, it is not simply a notation for drawing diagrams. What is the distinction between a language and notation? Notation is symbolic, it is specific. A notation has only a denotational semantic. I am keeping my fingers crossed. What does it mean? I will have to write a story to tell that this notation is exactly equal to only this, a symbol for multiplication. Whether you like it or not, what I am trying to communicate is a symbol for multiplication. Do not read anything more than that. Day after tomorrow somebody will come and tell this is something new. Please remember that I am projecting this as a crosswire in your telescope. The crosswire in your telescope, or when you are doing a prism experiment, this is a crosswire in that telescope which we are using it. So, different symbolisms, different notations. So, the best compilation is by Henri Dreyfus, has given a compendium of those notations, symbols which have been exceedingly useful to engineer all over the world. As I mentioned in the one of those earlier lectures, sometime 2-3 years after he passed away, that compendium was published, and it is a great reference book, a reference handbook. It is more than a notation, it is a language where people can easily grasp what is being said without really digging out what was the purpose of this. Suddenly if you show this, what do? It's like, please think that notation is something like playing dumb charades. Takes some time, takes some interaction, whereas language is something like reading this. It's so easy to read this. A mime is banking on lot of notations, whereas a description will automatically tell what it is all about. But a complete language for capturing knowledge, that's the reason why we invested on language, because it's easy to understand. Capturing knowledge, semantics is more important about a subject and expressing knowledge. Applies to modeling the systems. It's a result of unifying the information systems and technology industry's best engineering practices, principles, techniques, methods and tools. That is what I have been trying to tell. What is this unification doing? It is a specification, it is a visualization, it is a construction, it is a documentation, all in one. We were never happy, we were never comfortable with the idea of documentation coming from these areas, either specification or visualization or construction. From any of these quadrants, if you permit me to say so, in this oval, any of these three quadrants, this was not natural and easy. None of us were concentrating on this, we were never meant to do this also. It is just there, construct, you construct. That is how it was. So, documentation required a very completely specialized skill. We had non-technical edits, we have people who had no connection with these three, looking independently at any of these and trying to express in this manner, cross check, verify with the fellows who did this. That becomes a bigger headache. Now, unification has completely made this seamless. You can specify, visualize, construct, document, everything as in one lot. Everything flows simultaneously. This remains the number one goal of unified modeling language. Here we have programming languages, tools and processes. UML was originally conceived by Rational Software Corporation. Grady Booth's work was involved. It has involved the use of ADA in the application of data abstraction and information hiding with an emphasis on iterative software. James Rambaugh's work has involved various topics concerning research and development within the context of complex algorithms and data structures. Ivor Jacobson's work has involved the application of object oriented. However, we must understand that even though it appears prima facie that we have taken only the use case as an idea from Ivor Jacobson's method, that is a gift. It has simplified the development to an extent where we never expected, we never anticipated. Ivor Jacobson's method plus James Rambaugh's method on a mathematical basis was the concreteness that was found in UML. Grady Booth's abstractions and the way the definitions came in are absolutely essential for furthering the subject of object oriented. Unification creates a single consistent system from the most prominent methods within the industry. This is what I have been telling, all the three. The scope of UML encompasses focusing on a standard modeling language. The UML is defined by a set of documents from Rational Software Corporation. This is the place where Booth was there and object management group. Commercials, openness, all these things were happening, and after some time the object management group got so much entangled with UML that while associations and generalizations were more or less happening, aggregations, which is central for componentization, was virtually subdued in the exercise. It was not happening as we have anticipated. When the goal of object oriented included associations, aggregations, generalization, we were not able to get that aggregation. When, well, we can always argue that unless it is a vertical domain, aggregation which implies components and therefore reusability is not becoming apparent at all, unless it is a vertical domain. So, domains were like that, the work was like that, we are not able to see so much of aggregation. So, at this juncture Thomas Mowbray, he has created what is called Component Management Group, CMG, which forked out of Object Management Group. He was a very pioneering professional in OMG, but then there was a felt need to address aggregation as squarely as possible, because that was a highlight of object oriented which was getting subdued in all this. No method is perfect. UML is good in all these respects, but then the core idea, the driver of investments in object oriented, namely the promise for reuse, like we have matured the hardware market, we will simply put all the components, put them together and make it work, and that was becoming subdued. The domains may be the reason, the stakeholders may be the reason, maybe we have not been choosing problems appropriately, whatever it is, there was a felt need to get a focus on aggregation, which results in componentization, which results in reuse, and Thomas Mowbray is one other name which we need to mention, but then they created a component management group, because that very idea which is possible in UML, which is possible with OMG, but it is sublime, it is undercurrent, but when it happens we do not know what is the impact on so many people working together on multiple stakeholders. Therefore, it was forked off as Component Management Group, and I had a first hand working experience with Component Management Group until it became a commercial idea of Internet Component Management Group. For some reason we strongly felt at that time, when I am talking about this nearly 2 decades back. 2 decades back, at that time they were feeling that the idea of component management is more appropriate for the internet context, not for other development platforms, and it is true, today we are talking about Internet of Things. It is again considered the latest and technology. However, the Internet of Things as it manifests today is more on the periphery. We are still talking about things that can get potentially connected to the internet, a vision plan which was always there. Everything should be connectable, plug and play. As long as you have the port, it can be connected, you should be connecting to the world. The evolution of internet itself is a study, a lesson, a very stern lesson that tells that computerization is much better, pays off well, the quality parameters are much better when computers talk to one another, when they work together. Interoperability is the key for the success in this idea. So, we progressed, the very idea was like that. So, what we did was very simple, we said that ICMG, Internet Component Management Group, is an answer. Components may not happen in the way we have been expecting, or if it happens it will be subsumed in the UML exercise. Anyhow, everybody is talking only about UML. ICMG became commercial, and so far we have been talking about simple ideas, millions of devices getting connected, zillions of devices getting connected, all these ideas have been there. So, the UML definition has a notation guide. Please look up all these documents which are readily available on Object Management Group. All the documents here are there, and as I mentioned earlier, object constrained language specification. UML is a very comprehensive way of working through the object oriented from start to the finish. Well documented, well structured, fully open object management group. It has given us a great way of tackling the complexity with which we have to progress further. That is the complexity where the returns are likely to happen. We may not really appreciate until it is a lack of lines of code or more than that, and as I mentioned earlier, it is tens of lakhs of code which are there that need to be put together to do something more. UML extension for the object tree process for software engineering, UML extension for business modeling, it is also extendable to object tree process for software engineering, that is the object factory. Object factory was like a factory produces components, a factory produces goods, object should come out like that, component should come out like that. It remained a sublime idea warranting a component management group. UML extension for business modeling. So, we think that without deviating too much from all the nice things which we did until 2002 and later, we can still manage that aggregation, we can still manage a business dynamics. So, thank you, we will meet in the next lecture.